The vacuum pump system you will be operating was designed and manufactured in Traverse City, Michigan by National Vacuum Equipment, or NVE. Since our beginning nearly 30 years ago, we have strived to become North America's leading producer and wholesaler of vacuum pumps and vacuum system components. Currently, we operate with 70 employees from 2 plants in Traverse City, Michigan, and a warehousing facility in Fayetteville, Arkansas, with field representatives scattered throughout the U.S. We are the only U.S. company that does what we do. In addition to the high vacuum positive displacement Model 4310 blower you'll be using, we manufacture the Challenger Series rotary vane vacuum pumps, and we are the North American distributor for the Battioni and Pagani line of Italian-produced rotary vane vacuum pumps. A unique feature of NVE is that we have a state-of-the-art fabrication facility in which we produce vacuum tank and pump system components in various alloys. This allows us to offer complete, ready-to-install pumping systems like the one you'll be using. As a system user, you can be confident that all components are appropriately sized and specially fabricated for your system. Rest assured, you have a team of engineers and sales technicians capable of servicing all aspects of your pumping system needs. Should the need arise, you have the opportunity to talk directly to the individuals who designed and produced your vacuum equipment. Vacuum has been used for many years to move various types of product. The primary differences between a vacuum pump and the various product pumps you may have used or seen is that the vacuum pump only pumps air. A series of system components is put in place to help ensure the product being moved does not reach the vacuum pump. Every vacuum pumping system must include a tank, a series of valves, shutoffs, and a pump. The pump evacuates a significant amount of the air from a sealed tank, causing the remaining air molecules to be stretched out like rubber bands to cover the inside of the tank, thus creating a vacuum. One end of a hose is attached to the tank, while the other end is submerged in the product to be pumped. A valve is then opened on the tank end of the hose, allowing the stretched air molecules to pull closer together, thereby drawing the product onto the tank. The vacuum pump continues to draw on the tank during the pumping job in order to maintain the desired working vacuum level on the tank. Side eyes, or other types of liquid level indicators, are placed in the tank, allowing the operator to monitor the filling process. Once the tank is filled, a ball floats tightly to a seat in the top of the tank, shutting off the airflow to the system. All valves are closed and power is cut off to the vacuum pump. The remaining vacuum is then vented off the tank. The hose connected to the vacuum pump is removed and attached to the travel position. Once at the disposal site, the hose is reconnected to the vacuum pump, and the discharge hose connects the vacuum tank to the disposal receptor. For offloading, the vacuum pump becomes a pressure pump. This is done by moving the changeover valve handle from the vacuum position to the pressure position. Note that the air always travels the same way through the vacuum pump, regardless if the pump is under vacuum, pressure, or in the neutral position. The four-way or changeover valve is used to redirect the air from and to the vacuum tank. It is very important to make sure a valve is open in the tank before going to pressure. These pumps can put up significant pressure in a very short period of time, particularly with a loaded tank. There are relief valves in place to accommodate this, but safe practice dictates having a valve open in the unlikely event there's an issue with the relief valve. Many of you have very likely operated a rotary vane vacuum pumping system in the past. This system will be very similar in a lot of ways, with some key differences. The primary difference between a rotary vane pump and a PD blower is the design of the internal shaft that spins to create vacuum. This is called the rotor. A rotary vane machine uses a single large round rotor offset generally either top or bottom. As it spins, vanes are thrust out against the inner wall of the pump, creating vacuum pockets. The PD blower, on the other hand, has 2 cloverleaf or tri-lobe rotors, which spin opposed to one another, pulling pockets of air from the intake side of the machine around to the exhaust side. Though the clearances inside the blower are very close, there should be no touching or rubbing parts. The rotary vane pump uses and expels oil in its operation in order to lubricate the vanes and seal off the internal vacuum chambers. Since the PD blower has no internal touching parts, oil is not needed in the vacuum chamber. This means no daily filling of oil tanks and no daily emptying of oil catch mufflers, and no oil mess at the pumping site. Rotary vane pumps have a limited means of cooling and therefore are limited in the depth of vacuum in which they can work. The PD blower takes advantage of ballast port cooling, the practice of injecting cool air into the exhaust side of the machine, allowing it to work in full attainable vacuum for extended periods of time. The rotary vane pump utilizes vanes which rub on the inside of the casing and begin wearing the day they are placed in service. These vanes must be replaced periodically and can, and typically do, cause significant damage to the casing and rotors as grit and other impurities run through the system. Since the PD blower has no touching parts, there is only insignificant wear for the gear and bearings to deal with over a period of time. The tri-lobe blower design requires the blower to be spun significantly faster than a rotary vane pump. Rotary vane machines top out at 1200 to 1500 RPMs, where the PD blower is spun at speeds reaching 4500 RPM. This, coupled with the additional horsepower required for ballast port cooling, requires a substantial drive system, which in turn requires the operator to exercise great care in startup and shutdown of the machine. Though the PD blower does not require an oil catch muffler like the rotary vane machines, it does require silencing for both the exhaust and the ballast ports. The PD blower, like the rotary vane machine, has a final filter on the intake side of the machine which must be cleaned periodically. Unlike most rotary vane pumps, the PD blower has a ballast air inlet filter which must be kept clean, and again, unlike the rotary vane machines, the synthetic gear lube on both the drive and non-drive ends of the blower will need to be checked and periodically changed. With either machine, it is very important to keep grit and debris from entering the pump. This will cause catastrophic pump failure. NVE has teamed with Hog Holland and ITI Truck Bodies to develop a pumping system uniquely suited for Hog Hauling's pumping operation. We have attempted to keep all maintenance points and operational aspects of the system easily accessible. Your blower is mounted on the frame behind the driver's side of the cab. A shaft runs from the PTO, or transmission, to a right-angled gearbox, which in turn feeds power to the blower. Be sure to check your dash for proper engagement and operating RPM. Engage the machine slowly, feathering out the clutch as best you can. The gearbox is a 1:2 ratio, meaning that the input shaft is doubled at the output or blower shaft. The cab. A shaft runs from the PTO, or transmission, to a right-angled gearbox, which in turn feeds power to the blower. Be sure to check your dash for proper engagement and operating RPM. Engage the machine slowly, feathering out the clutch as best you can. The gearbox is a 1:2 ratio, meaning that the input shaft is doubled at the output or blower shaft. This gearbox uses a synthetic lube, which should be monitored and changed on a periodic basis. The gauge you see on the face of the machine is the vacuum pressure gauge. Though these are not always 100% accurate, they should give you a reasonable idea of the vacuum or pressure your blower is creating. On the left-hand side, behind the blue hose, is a temperature gauge. The maximum temperature you want to see on this gauge is 200 degrees Fahrenheit over the outdoor temperature. So, for example, if it is 60 degrees outside, your gauge should not rise above 340 degrees Fahrenheit. If the temperature is -10, on the other hand, the top number should not exceed 270 degrees, etc. The most important thing to remember about the temperature gauge is consistency. If you start seeing sudden changes in the temperatures you are accustomed to, it is a sign we should check out the system. The blue hose in front of the temperature gauge is connected to a pressure relief valve. This pressure relief valve is preset to relieve or pop off at 10 psi. You will notice the pressure level will drop and maintain after the valve pops open. This should be around 7 psi. Directly across from the pressure relief valve is a plate held in place with 4 thumb nuts. Behind this plate is the intake filter, which is round and constructed of stainless steel. This filter is cleanable and reusable. Given the very close tolerances inside the machine, it is imperative the filter be in place when the machine is in operation. This is the last hope of keeping grit and debris out of the blower. The frequency of servicing this filter will depend on several variables relative to each job: working vacuum level, type of product, grit content, airflow, etc. Start by servicing the filter once a week, then adjust your frequency as appropriate. When the filter clogs up, the performance of the system will decrease, though the machine itself will typically not overheat as long as the ballast air inlet is clear. Behind the final filter is the intake air check valve. The purpose of this mechanism is to keep the air from rushing back through the blower when the system is shut down while under vacuum. When shutting down the pump while the system is under vacuum, air will bleed through the ballast air cooling system, but the backflow should not cause the blower to spin backward. If the blower freewheels backward upon shutting down the system, the check valve is the first place to look for a problem. In the center top of the machine is a 4-way or changeover valve. The air always flows the same way through the blower, so the 4-way changeover valve redirects the air from vacuum to pressure or to and from the vacuum tank. Never swing the valve from one side to the other without first relieving the tank of vacuum or pressure. Please move the handle to the neutral or central position and wait until the air in the tank is neutralized. There is an adjustment at the bottom of this valve which sets the spring tension. Take care not to over-adjust, making the valve handle either sloppy or unmovable. There are also 3 greasing points on the valve. Take particular care not to over-grease the fitting on the top of the valve. Down on the side of the blower on either end are the sight glasses for viewing the gear case level. This should rarely fluctuate, if at all. Be sure to check it when the truck is level and the blower is cool and has not been run for an hour or so. If you're confident it is needed, lubricant can be added through the plugs on the gear case covers above the sight eyes. If the gear lubricant is overfilled, you will notice a weeping of lubricant at the midpoint between the outer casings and the vacuum casing. The level will eventually self-correct. Following the piping up to the top of the frame, you will see a couple of fabricated boxes. The bottom box, which is painted black, is the exhaust silencer. This box always remains sealed. A series of tubes and baffles runs down the length and back up. There is no drain on this unit. The final exhaust is run up and is deflected to the opposite side of the truck. Note that this becomes the intake port when the system is under pressure. Immediately above the exhaust silencer is an aluminum box which contains both the moisture trap and the ballast air tuner or filter. The moisture trap is on the driver's side end of the box. You can see the intake air line which connects to the inlet side of the 4-way changeover valve. This unit is designed to capture liquid in the event of a spillover from the tank. A float ball inside the moisture trap, behind the bolted cover, floats up with the spillover liquid until it seats against a ball seat and shuts off the air to the system. This shutoff arrangement mirrors the shutoff in the top of the vacuum tank and is strictly a backup system. Hopefully we never have to use the float ball in this unit. The trap is bound to accumulate moisture from the airflow, however, and must be drained at least daily, if not after each use. On the passenger side of this box, you will find the ballast air filter. The grate on the back side of the box, facing the front of the vacuum tank, always allows fresh air to enter the system. The fresh air is filtered and tuned or silenced, and then is fed into the exhaust side of the PD blower. If you encounter heat issues with your machine, the ballast air system is the first place to check. On this end of the box is a door held on by 4 thumb nuts. Is the ballast air check valve. This consists of a flapper plate which opens when the unit is under vacuum, allowing cool air to enter the machine, and it closes when the operator changes the unit over to pressure. This allows pressure to be built on the vacuum tank and not escape through the ballast air system. It can be adjusted to give the operator a more comfortable noise frequency. Also contained in this side of the aluminum box is the ballast air check valve. This consists of a flapper plate which opens when the unit is under vacuum, allowing cool air to enter the machine, and it closes when the operator changes the unit over to pressure. This allows pressure to be built on the vacuum tank and not escape through the ballast air system. The first step in operating the equipment is to disconnect the vacuum hose from its travel position and connect it to the vacuum line inlet. Be sure to open the isolation lever valve in the line and make sure the blower changeover valve is in the vacuum position. Carefully and slowly engage the PTO, then run the cruise control to the RPM specified on the dash of your truck. Now you can lay your hose, open the load valve, and proceed to load the tank. Follow the company procedures as to cleaning out your hoses and the tank fill level. Disengage the blower and bleed the vacuum off the tank. Disconnect the vacuum line from the tank and reconnect it to the travel post. For discharge, make sure the blower changeover valve is set to neutral or the pressure position. Connect your vacuum line, now the pressure line, and your tank discharge lines, and open the discharge valve before carefully and slowly engaging the blower. Never operate the system under pressure without having a valve open in the system. After discharge, disengage the blower and bleed off all pressure from the tank. Reconnect the vacuum hose to the travel post. In cold conditions, it is important to make sure the blower shaft turns over freely before fully engaging the PTO. This is done by gently and slowly releasing the clutch. Introduction of RV coolant may be required to neutralize any moisture that might be trapped in the blower. Also, in cold operations, it is important to allow the blower exhaust temperature to rise above 100 degrees Fahrenheit before operating in full vacuum. This should not be an issue as the hog hauling trailers are set up to relieve vacuum at about 21 inches, well below the attainable full vacuum level. When the blower system is going to be pulled out of service for an extended period of time, it is important to always make sure the vacuum line is disconnected from the tank and securely fastened to the travel position during any transportation. Thank you for your attention to this presentation. All of us at NVE are proud to have Hog Haul and use our equipment. Please let us know if there is anything we can do to better assist you.